This is our function generator. Sometimes we don't want the signal to be constant in time like our DC power supply puts out. We want the voltage to change in time, like a sine wave or a square wave, and that's what we use this for. The buttons over here can be pushed to select a sine wave or a sawtooth wave or a square wave. The buttons over here are there to select the frequency. How fast does that wave change? So you push one of those buttons. That's 100,000 hertz. But you can see those buttons are pretty far in between. 1,000, 10,000, 100,000 hertz. This wheel is the multiplier. So right now it's set to 1. So this is reading 100,000. But if I turn it to a half, it's a half times 100,000 or 50,000. If I turn it up to 2, it's 2 times 100,000 or 200,000. So it's a multiplier. So between the wheel and the buttons here, you can get any frequency you'd like. The frequency, again, is how fast that signal is changing, how many cycles you get per second. So in addition to those controls, we can also control the amplitude. So we can turn that down or up, and that controls the peak-to-peak voltage, how much voltage we're getting out peak to peak. Across the bottom are various outputs and inputs. The ones that we use are the two on the right. We typically just use this one. This is the high voltage output. The other output also works for most of what we do. Those are the same thing. One is limited to a slightly lower voltage. The other one will go up to 20 volts peak to peak. So there's our output. Here's our control for the peak to peak voltage. And these controls for frequency and our multiplier. This is an oscilloscope. It shows us how the voltage is changing as a function of time. So if you remember, we had a DMM that would measure voltage, but it was mostly useful for measuring DC voltage, where it's not changing in time, and it'll just give us the value there. Or if you set it to AC voltage, it will give you what's called the RMS value, the root mean squared value, which is kind of an average of the changing voltage. But it doesn't really tell you how the voltage is changing in time. The oscilloscope shows you on a nice graph how the voltage is changing in time. The horizontal axis is the time axis. The vertical axis is voltage or electric potential. This one has two inputs, channel 1 and channel 2, and they're controlled with these knobs. So once the input signal is being displayed, you can use these knobs to change the scale, and it'll scale it up or down. And the other knob here on where it says horizontal, that's for changing the scale in the horizontal direction, the time axis. So there are a lot of controls here that I don't want to get into right now, but these digital oscilloscopes are really nice. The main thing you want to take from this is we've got two inputs. We've got some controls here to change the display. So how does it going to look on the display? Scaling it up and down, things like that. And the other thing you want to know is up here in the corner, there's a button called Auto Set. And that button helps dial in everything. Sometimes you get a little out of whack and the controls are off and you don't really get a nice clear picture here. Just push the Auto Set button and it'll get you really close to where you want to be. It dials things in about where it thinks you want to be. It may not be exactly where you want to be, but once you get close, you can change things with the other controls ever so slightly.